flying for the next 10 hours. Head to Florida.
Last time on the LS vs Coyote engine shootout, we flew to Texas to check out the LS engine build at LME. We met Brian Nealon and his team, and we got the down low on how they plan to win the competition. Plus, we got to see the engine come together, and we saw what parts they chose for the build and why. In this episode, we're flying to Florida to check out MPR, meet Tim Eichhorn and his team, and see what they have cooking to try and take out the LS.
Just landed in Florida.
Hey Brandon, you know some pumpkin holes? We just showed it to MPR. Now we gotta find Tim, figure out WTF, what's going on. Tim, what's up, man? How's it going?
Brian, nice to meet you. How you doing?
Good to meet you. So before we get into the strategy and the engine build and the parts, talk to me about you, your background, and just where MPR was compared to where it is now.
I've been building engines for about 26 years. We started MPR 13 years ago. We moved up here to Boynton Beach around 7 years ago. That was an opportunity for us to build our name and build the machine shop up to pretty much where it is today. It's been a long journey, but it's been very exciting.
Let's talk about how you plan on taking out that LS. There's multiple different points you can win in different areas. Are you going after all of them, or are you going after a couple specific areas? Talk to me about that.
We're going to try to go after all of them, of course. I mean, if you're going to win it, you want to win big. But I know for sure the one that we're going to win is horsepower per cube inch. But the other points we started focusing on that as far as peak, average horsepower and peak power and torque. The Coyote stuff, we have to use a lot of the factory parts. We don't have the 3,000 sets of heads we can pick for a Coyote like the LS does. So we have to work with what we have done. Luckily for us, we've done a lot of Coyotes, a lot of championships with a ProCharger that actually kind of gives us a little bit of edge on the Coyote stuff where we think we're going to be ahead on it.
Where do you think the LS could possibly outshine the Coyote?
The LS, it's the torque. I mean, it's going to be where the LS is going to make a lot of torque. It's going to be really hard to keep up with that. It's an average between horsepower and torque, so I'm hoping our horsepower is going to outweigh our torque, so we can kind of average it together, and this way we get our number to beat them, and that's what we're after.
It sounds like a good plan. Let's get out to the shop and start assembling that Coyote.
Let's go get that number one ready to go.
Let's do it. Tim and his team are going after as many points as possible. They went with a factory long block from a 2015 Ford pickup as a base for their build. They added aftermarket sleeves to handle the boost and CNC porting on the heads for better flow. With a higher compression ratio of 12.25 to 1 and an F1A94 ProCharger, Tim's trying to make this combination as efficient as possible. They're topping off the setup with a Holley intake manifold and throttle body to make sure the engine is ready to handle the boost from the ProCharger. All right, Tim, this is the Coyote that is going to take the LS down. Talk to me about some of the stuff you guys have done, because I see some weld here. These are obviously not the factory liners, and you guys have done quite a bit of stuff.
Yeah, what we did is we started off with a 2015-2017 truck core, basically just a junkyard motor. Got it all apart, make sure everything was good. We machined it for the dart and sleeves. Did our proprietary machining process. We do a lot of prep work to these engines to get them to where they're going to handle that kind of power. Of course, we weld here for the gusset, for the back head stud that kind of pulls and will crack it. Also in the back over there. It's kind of one of those things that we want to make sure we take care of a problem before a problem exists. Other than that, then we kind of prep the block. We deburr the whole block, go through it, make sure there's no sharp edges, take out all the casting flash, make sure everything's smooth and ready to go. No burrs or anything that kind of mess up any bearing clearance or any kind of clearance issues that we have, because these are tight clearance motors.
So you said casting flash. What is that exactly?
Casting flash is a process where when they cast an engine, there's always some sort of pieces where you can kind of rub it off and stuff comes off. If you ever look in a stock motor, an oil pan, you pull it down, especially on the first oil change, it almost looks like a blown up motor. So what we do is we kind of get rid of all that so nothing can get in and introduced into the engine to cause an issue down the road. It's just one of those things that you just want to make sure you have everything smooth and clean, and cleanliness is the best thing in an engine build, no doubt about it.
So right behind me, we're actually watching the block being machined for the flanged sleeves that are going into it. And it is really, I don't know, it's very titillating to watch. So it's cutting the groove up in the top of the block right now for the flange on the sleeve so that it doesn't move around and doesn't walk inside the bore, which is pretty cool. know that a factory Coyote engine can support a lot of horsepower, but how much power do you feel comfortable pushing stock sleeves as compared to these aftermarket liners?
Well, what it is, you know, the stock sleeves, when you do rods and pistons and do the prep work and everything, I rate them to around 900 horsepower. After that, then the block becomes the issue. Well, the block has an issue where it'll start cracking right above the water jacket port because of the thrust load on it. So when that happens, it cracks the block and then you just ruined everything you just did. So if you're gonna keep it below that power level, you wanna make sure that you're gonna keep it that power level, but the guys get greedy, and when they get greedy, they'll be seeing me again for a dart sleeve block.
And how much horsepower can these type of sleeves support? Because I know that there's a modular sleeve, there's flange sleeves.
These are the flange sleeves. I mean, we rate these, we got guys making over 2,000 horsepower with these sleeves. So they can support a lot of power. Now, of course, there's a few more stages of prep that we do in order to sustain that horsepower. So this within a billet I-beam rod dealer we're doing here, I mean, this thing should be good for 1,500 plus.
All right, so this is the engine block that we're starting with on the Coyote build, okay? And the sleeves are all installed and done. They look really nice. They're a lot thicker, a lot more meat, so they're gonna be able to hold up to a lot more cylinder pressure, and overall, just a lot more horsepower. It's a really good platform, and it's nice because it's aluminum, so it cuts down on the weight. You know, whatever car you're gonna put it in, the aluminum block, even with sleeves, is still way lighter than any cast iron block. So let's get started putting this thing together. So Tim, now that we've talked about the block, you've filled us in on the sleeves and your process. I see a crank sitting over there, and let's talk about that. Is it a factory forged crankshaft deal, or what is it?
The factory Coyote cranks are forged from the factory. It's an 8 counterweight deal, so it has a center counterweight, really, really smooth crankshaft. What we do is the prep of the crankshaft is pretty much we clean it, polish the journals. Of course, we balanced it for the heavier stuff. You can see the heavy metal that we had to use in here to get it balanced. Because this is a blower motor, we're going to take all the precautions. We're going to go ahead and put that double key on the snout over there to keep it from spinning that balancer on the snout. So it gives us a fighting chance with that serpentine belt. Our next step here is we're going to go ahead and make sure we're going to get our journal sizes so we can get our bearing clearances all set for what we want to do with it. So we're going to go ahead and mic the crank and get everything all set.
So on the connecting rods, what are they length and what kind of horsepower are they rated for?
They are 5.933 lengths, factory Coyote length. Horsepower wise, we got guys making 2,000 horsepower with these rods. Now the only upgrade for manly on this is a 300M rod. And of course we've made like 3,000 horsepower on some of those.
And what rod bolts are in these? I know they're ARPs.
They're ARP 2000s. They do have an upgrade to a 625. And a setup like this, I don't think it's necessary. You know, usually the guys are going to spend a little more RPM and stuff like that. We want to make sure they have a better rod bolt and stuff like that. This thing here is probably going to be, you know, just a tick under 8,000 RPMs.
And that's exactly what I was going to ask next, is what RPM do you think this thing is going to make peak power at?
I would say, depending on the blower where it peters out and everything and how the dyno set up as far as the induction goes, I mean, 8,000 RPM is not a problem.
Tim, for people that are looking to build something like this in their garage, they might not understand or they might not care about the clearances that you're checking because, well, it's a factory crank, I got standard bearings, I'll just put it together and it'll be fine. Why is that kind of a flawed thinking?
The flawed thinking is unfortunately, you know, we have some issues with bearing tolerances and stuff like that. So, I mean, it might take 2 to 3 sets of bearings in order to get our clearances where we want them. These are tight tolerances motors, so we need to make sure that those bearing clearances are on the money. I mean, some of these things run between 1 and 2 tenths, you know, to 2,000s.
And when it comes to spinning 8,000 revolutions per minute on this crankshaft, everything needs to be exact.
Exactly. Tight tolerance motors require, you know, precision machining and precision assembly.
So Tim, I've noticed in basically all of your engines on the main studs and the head studs, you guys use ARP stuff.
Yeah, the factory stuff is torque to yield stuff. That does not belong in a high performance engine. ARP does a great job of providing us with fasteners that hold the power. Never have any issues with their stuff. Always a quality product.
Yeah.
So it looks like Tim is done getting the crank all measured out, making sure clearances are where they're supposed to be, and now are you ready to put it into the block?
No, we actually have to make sure that our bearing clearances are set. So what we're going to do is we're going to go ahead and lay them all in there, torque all the main caps down, and we're going to get our measurements here. What we're going to do is we're set our mic to our highest setting of what we got here. Now this crankshaft was pretty good. It was only maybe a couple tenths difference in variance. So what we'll do is we'll get our dial bore gauge set up, and then we'll subtract our measurements, and there's our clearance band. So we'll make sure everything's all set. We'll get to go. We've already lined on the block, so we know all the main caps are within tolerance. So everything should go pretty smooth. So let's check it out.
So you're getting ready to put the bearings into the block, right?
Correct.
And they're from Molle. Do they come in different thicknesses, extra oil clearance?
What it is you have a standard bearing and then you have an extra clearance bearing. So what it is, if you don't have enough clearance, you know, say it needs to be a little bit looser or whatever else, you can go ahead and mix and match those bearings. So if we're gonna mix and match, we wanna make sure that they're all matched up on the top and all matched up on the bottom side of it. Say our bearing clearances is coming at like 9/10, we want 1.5. So what we'll do is we'll use a half shell bearing with an extra clearance, and that should give us our extra clearance.
And on those bearings, I see that they're coated. That's like a dry film lubricant, right?
It is. On this one here, the rod bearings were coated. What it does, it gives you an extra barrier. So, you know, these things are tight tolerance motors, so when you first fire them up, the oil pressure's not there or whatever. The coating actually takes the brunt of the start up. And not only that, you get a better, smoother surface, so when the oil's going through it, it's a lot smoother.
Well, it seems like Molle has their stuff figured out.
They do.
Let's put those main bearings in and get the caps torqued down and make sure everything's good. Hey, Brandon.
Put the camera away.
Where can people go if they want to find out more information?
Oh, horsepowerworks.com.
What did you call me? Okay, so I think the next thing you're going to put in is the oil squirter block-off plates, right?
Correct. Yeah.
And I'm really curious because in my mind, I would want to keep oil squirters to keep the bottom of the piston cool, but maybe that's a myth. I don't know.
Well, in some situations you do want to keep it. What we do is we have these little billet block-offs that get rid of it. Now, the reason why we do it, there's a few reasons actually. On some of these motors with the bigger rods, we have an issue with clearance problems. Okay, another thing is too, some piston designs, also another clearance issue is the piston's going up and down with the way the squirters were designed from Ford. So what we do is we block it off, gives us the clearance for the rod to throw. Not only that, by getting rid of that oil squirter on the bottom of the piston, it gains 8 horsepower.
How?
The weight of the oil on top of that piston, man, it gains 8 horsepower.
No crap.
Fact.
All right.
Not only does it give you more clearance, but there is a horsepower advantage to getting rid of those oil squirters from the factory.
I never would have thought of that. I never would have thought that.
Yep. So the LS boys, we got an 8 horsepower advantage right here going at you. So we got our Cleveland main bearings all, you know, surface finished and everything. We get rid of all the burrs and everything before we put them in there. So we do spend a little bit of time on the bearings to make sure there's no burrs or no hang-ups. You know, out of the box, they're just production pieces. So, you know, you spend a little extra time just to kind of go through them. Because, you know, a little bump on a bearing is a mountain to a crankshaft.
So we're putting the crank in. Tim, what kind of horsepower have you seen guys make on a factory forged crankshaft?
Well, you know, Justin Jordan just went 684 at 2 and change. So he had to be making probably 1,800 to the tire. So that's over 2,000 horsepower. So, and we just got his motor back in for a freshen up, and let me tell you something, man, that Coyote crank looks right as rain, man. It looks brand new. The factory pistons have a dome from the factory, so it's not like we just went with a bigger dome. This thing should be about 12.5 to 1 by the time we're done. This is a max effort deal though, so we're going after it. We went with the Manley billet I-beams. We went with their Turbo Tough rod. It has a thicker beam, wider big end. You know, the rods kind of put the budget in a tight spot as well because they're, you know, it's not the cheapest Manley rod, but we wanted to make sure that we don't have any flex or anything's gonna happen, you know, when we put this thing on the dyno and make power. We're checking the oil expander ring tension on the cylinder wall. Too much is gonna cause an issue where it's not gonna control the oil because it's gonna kind of scrape and not do its thing. Too little, of course, and you're not gonna have enough oil control. So there's a balance there. Now on the aluminum, you know, the aluminum block stuff is gonna grow, so we want a little bit tighter to start off with, just for the fact that we know it's gonna loosen up.
All right, so the valve springs and the valves are installed in the heads, and now it's time to get them bolted on to the block. Short block's assembled, ready to go. Now that you have the heads on, let's talk about the valve springs, the valves, and the porting that you guys do on these cylinder heads, because I'm sure you guys have a program, you do these like clockwork, and they're gonna make a lot of power.
We hope so. The deal is with the Coyote heads is that we have to utilize a factory casting. The GT350 heads were our first choice, but it would throw the budget way out of whack. So what we did is we focused most of our budget on the porting of the heads. What we did is we ran our blower port CNC program through it. We put bronze guides in it, and what we did is we got with Ferrea and got our inch 500 valves and inch 262 valves, which are bigger, 1 millimeter over, to get that boost in there where we need to get to fill up that chamber. After that, we got with Manley and we get our valve springs. We did their high lift valve springs, titanium retainers, so we can run more lift on the camshaft. We're almost 580 lift on the intake and 512 on the exhaust.
That's quite a bit of lift on each side. And you also went with a different valve seat, correct?
We did. We got with CHE and we get some valve seats. Because we run the inch 500 valve, the +1, you can't fit that valve on the factory seat, so we have to put a bigger seat in it. So what we do is we go in there, we get a ductile iron seat, cut it bigger, put it in there, and put our valve job on it, and it's ready to go.
When people talk about boost and porting cylinder heads and stuff like that, a lot of times it can come up, we'll just run a little more boost and it'll make the power. What is your argument to that?
Well, that is true, but what we do is through our port programs, we keep the velocity where it needs to be. A lot of times you make the port really big, it just slows down the airspeed. Through years of development and working with a lot of guys, that we've been able to keep the airspeed going, which actually we're packing more of that air into the cylinder and not just having it tumble around doing nothing.
And keeping these heads sealed to the block, you have ARP head studs, but there's something different with the washers, right?
What they did is they actually came up with a serrated washer a few years ago, because what it was the Coyote heads and some of the Mod Motor heads had too smooth of a finish where the actual washer would sit. So what was happening is you were actually over torquing that stud. So you're thinking you're going 80 pounds, you're actually going like 120 pounds. So all you do was stretch that stud and all of a sudden snap. So ever since they went with that serrated washer, we get a pure torque reading on every single one of them.
What head gaskets are you using and why?
We only use Kinetic here at MPR. They seal the best and we don't have any issues with them.
Perfect. So now what's next?
What's next is we're going to get our comp cams, we're going to get our hydraulic roller lifters ready to go, our roller followers, and we're going to put our comp cams in there and we're going to get them all degreed up.
All right, Tim, you have everything timed. Cams are in, and I think we're ready to do the final touches, the covers and everything, but I want to talk about the cam specs and why you guys went with a custom blower cam.
We went with a custom blower cam because we wanted to provide it to our specifications. Now doing that, this is a shootout, we're trying to make max power, we want to make sure that our cam time is where we want it. We want to open that intake valve when all that boost is right at peak. We want to get that exhaust out of there so that combustion can take place and make that power. So what we did is we actually have our lockouts here. We've degreed the camshafts in. 110 intake center line and 120 exhaust center line. We want to make sure we get that low end as long as we carry that peak torque and everything else that's going to make this thing sing. So comp cams gives us a specification on where they want everything. So we try to adhere to that as best as we can, but we do play around with it. We have played around with it because we built so many of these Coyotes that we kind of know where this camshaft really needs to be, especially on a dyno shoot like this, especially with a blower. We're ready to go as far as these specs are right where we want them. 244 degrees of intake duration and 250 degrees of exhaust duration. Our intake lift is 576, our exhaust lift is 512.
What was the compression ratio on it?
The final compression ratio came out to 12.25 to 1.
And that is pretty high.
We want that cylinder pressure to make that power.
Okay, and on top of the compression ratio, you guys want to run 30, you're hoping for 30 pounds.
Whatever that ProCharger is going to put out is what we want in this motor.
And it's going to make some serious power. I want to talk about the degreeing because some people might not realize how much time you have to take to degree a custom cam, especially when you're doing your lockout plates. Talk me through that process because I know that it took you a long time to do this motor, and why is it important to do that rather than just lining up the marks from the factory?
Right, well the pushrod motor, of course, you have one camshaft and you're moving from the crankshaft relation to the camshaft relation. Now in this area you have the crankshaft relation and then you have 4 camshafts, intake, exhaust, intake, exhaust. So you got to get those timing events in relation to the crankshaft as best you can. The problem is that these lockout plates are very adjustable. They're very precise. So you move it a little bit, you can move this thing 1/4 of a degree. So it just takes a very long process to get those numbers, what you were looking for. It just takes a while.
Well, now that we have all the specs, we know everything that's going on, the compression ratio, the lift, the duration. It's gonna make some serious steam, but in order to do that, we need to finish all the little things, the covers, front cover, rear cover, valve covers. You ready for that?
I'm ready for that. We're ready to get all the covers on this thing so we can put that ProCharger on there and button this baby up.
Let's get them on.
Awesome.
I leave for 5 minutes, you've already got the thing done.
We're ready, man. We're ready.
So talk to me about the finishing touches. I didn't even see the blower, the intake manifold, or anything go on.
With the budget we were allotted, we were able to get a Holly Sniper intake manifold for it. Now we know these work. We have a lot of customers that win races with this intake manifold. In order to win races, you gotta make horsepower. So we know it makes horsepower. And then we ended up going with some Deutschwerks 2200cc injectors.
It's still Deutschwerks. Deutschwerks injectors.
2200cc injectors to feed this puppy because it's going to need fuel to make that power we're going to make. So we got to make sure we're going to keep this thing fed.
So obviously this intake manifold is really big. What throttle body did you go with to match
We
it?
ended up going with the biggest one that Holly makes. It's their 90mm throttle body, one with mechanical linkage for the dyno, no fly-by-wire deal. So we're going to make sure that puppy stays open all the time and no electronics to make that thing close shut and not give us the horsepower we need.
And there's a lot of air that's going to be forced in by that ProCharger. Oh, yeah. What head unit did you go with?
We chose an F1A94 head unit because the Coyote's still a small displacement engine. So we want to make sure that we're going to utilize everything that's going to throw at it. Also that, we want to make sure that the air gets thrown at it, the gear drive, the impeller speed, everything is pretty much matched to this Coyote to make the power.
And what damper did you guys go with on the front of this motor?
We use ATI stuff on all our blower stuff. So we have put an ATI harmonic balancer with a double keyway. We have the keyway double hub from ATI. Best balancer out there. We have no issues with them, man. It should keep that crank nice and smooth.
It has been such a pleasure to see you guys put this together, and I love all of the finishing touches. I mean, MPR is all over this thing, and I'm curious why you just put it everywhere.
Well, we put it on there because after the dyno, we want to make sure whoever makes a trophy can spell our name right. MPR Racing Engines for that #1 spot.
Thanks to our friends over at Summit Racing Equipment, we know exactly how much of the budget was used to purchase the engine parts and to put this setup together. All in all, MPR used $14,668 of the total $15,000 budget. And make sure you stay tuned, horsepowerwars.com, for the finale of the LS vs. Coyote engine shootout, where this Coyote and the LS from LME is going to be shipped to West Tech. We're going to dyno them. Whichever one makes the most horsepower is going to win.